Let's get started with some beginner AI for non-player characters, or commonly known NPCs. If you are new to behavior trees or looking to get extra tips and ideas, this video is for you. In this part, we will be making an AI-controlled NPC that walks around in a couple different ways. We will cover setting up the character with an AI controller, a blackboard, and behavior trees to make decisions. If you find this useful, like and subscribe. Leave a comment about questions or what you want to see in the future. First, we will create a new project and adjust my layout so you can see everything that I'm doing. A new folder to keep things tidy, and make a new blueprint class for the AI NPC. Set the animation class and skeletal mesh to your desired classes. I will be using Quinn for this example. Move the mesh into position and rotate it to face forward. If you forget to check use acceleration for paths, your NPC will slide instead of walk. To set up the AI controller, create a new blueprint class and search for the AI controller parent. In the highest level of your NPC blueprint, set the AI controller class to the new AI controller blueprint you just made, and change auto possess AI to place in world or spawn, depending on how you plan to use it. In the AI controller blueprint, let's explore a quick overview of what you can do here. This blueprint runs when the AI possesses and takes control of your NPC, so you can run just about anything in this event graph. I'll demonstrate by having it print something as soon as it takes control. You can see the text on the screen as soon as I hit play. The cool thing here is that each instance of the NPC is separate from the others, so in Tick, we can tell the NPC to display its name. We'll make some copies, and you can see that each instance displays its name in every frame. Let's set up a Blackboard and behavior tree. I like to do this by creating a behavior tree first. Find this under the Artificial Intelligence heading in the right-click menu. In the behavior tree, select New Blackboard in the upper left and verify that it's set as the Blackboard asset for that behavior tree. You can quickly switch between the behavior tree and the Blackboard with the buttons in the top right corner. To keep it simple, the Blackboard just gives you a place to store variables called keys. You may add as many as you need. These keys can be set to whatever type you want or need. I'll create a few. Let's make some locations as vectors. And for something different, I'll make a key for an object to target and a bool if we have a target. We won't be using all of these examples in this part. These keys are only used by the controlling NPC by default. If you want them to share a key, you can check instance synced, and if you update that key, it changes all the instances of the NPC's keys. This is useful if you have something like a horde of zombies chasing a player. If one knows, they all know. Let's talk about behavior trees now. To have your behavior tree run, you just have to tell the AI controller to run it at begin play. Now let's step back and take a look at how behavior trees operate. There are 3 types of composite nodes in Unreal 5, each act in a unique way. In this part, we will only be discussing 2 of them. Sequence nodes only pass if all the tasks below it pass. The tree always performs the operations left to right. Let's look at this fantastic artwork to explain. Behavior trees always start at the root, and the root must go to a composite node. Here it goes to a sequence node that has 3 tasks attached to it. The operation runs down the left side to get to task 1. Let's say task 1 passes. It then runs task 2. Task 2 passes and runs task 3. Task 3 reports success, and the sequence node is considered successful. Let's say task 2 is going to fail. Task 1 will run and pass. Task 2 will run but hits a failure and reports unsuccessful. This causes the sequence node to fail instantly and not run task 3 at all. Let's say the sequence node has 2 sequence nodes beneath it, each with 3 tasks. If each sequence passes, all the tasks will be performed. Now let's say that task 2 fails. Again, task 3 won't run. Since the sequence node it's attached to now fails, it won't run the other nodes either. If task 4 fails, everything after that fails also. Selector nodes act differently. We'll replace the topmost node with a selector node. Let's say all the tasks pass here. Once a selector node gets a pass, any success at all, it will not run anything after that. It will try everything else until it gets a success and will only fail if everything fails. Back in the editor, let's add a sequence node and just a default wait node to watch it run. You can see that it runs the wait node and just does it again in a loop. Let's make our own action called a task. Click New Task at the top left of the behavior tree and name it. My task will pick a random point the NPC can get to and move there. So I will call it Patrol Random Point. Start AI tasks with Receive Execute AI to start running the task as soon as the behavior tree gets this task. I will use the node Get Random Location Navigable Radius and use the actor's current location for the origin. Set the radius so it will pick within whatever distance you want. I used 1,000 units. Then add AI move to and set the random location result to the destination pin. Add the task to the behavior tree. I want the NPC to walk, then wait, so I added the patrol task to the left of the wait task. You can see when I hit play, my NPC is not walking, even though the behavior tree is running. Of course, I didn't say where he was allowed to walk. Add a nav mesh bounds volume to your level and expand the box brush to cover the area you want to be able to walk. Press P on the keyboard to verify it's working. Green means it's walkable for the NPC. Ah, there he goes. Wait, now he's only moving one time. Oh, you can see that the behavior tree just stops on the random patrol task. I didn't give it any way to say if it passed or failed. The Finish Execute node fixes this. There, it works now. But it's a patrol, not a sprint. Let's change how fast he can move. A cast to get the movement component and set the walk speed to something lower. Much better. I think that we've all had enough. Keeps you up at night, yeah. What happens if I switch the random patrol and the wait task? You see the same things happen, but it waits first and then it moves. I can move some panels around so that you can see the behavior tree and actions together. Let's add a few more and watch them. You can also pick what NPC instance you want to watch. I don't like that they all walk at the same speed. Let's randomize that a bit and give some variation to the NPCs. Let's start using some of those Blackboard keys that we set up earlier. We'll have the NPC blueprint come up with a random walk speed and send that value to the Blackboard. We'll have to create a new key to hold it. We must tell the editor what kind of value we plan to set and what key we are setting. There are other ways to do this, but make literal name is the easiest to explain here. I'll show other ways to work with Blackboard keys in a future video. The key name must match exactly to the name in the Blackboard. Watch for spaces and capital letters. I usually copy and paste to avoid mistakes. In the random patrol task, we will get the value from the Blackboard and use it to set the max walk speed. I'm not convinced it worked. They kind of all still look the same. Let's see what the speeds are. Yeah, they are different, but too similar. I'll really spread out that range to see it work. Okay, it's working. I can shrink that range again. I really don't want my NPCs wandering in any which way they please. At least not all the time. I want them to go to a place of my choice. Let's make a new task called Patrol to Set Point. We'll finally make use of the start location and patrol location keys now, so we'll need to set them to the Blackboard in the NPC begin play. Collapse to a function to keep it neat, and set the starting values like before. But how do I know where to patrol to? I could manually type a location, but that would be a lot of work each time I added a new NPC to the level. Let's create a component in the NPC to mark a place for us. Add a static mesh sphere and scale it down. I called it Patrol Point and made it a brighter color to see better and made it hidden in game. Oh, Don't forget to turn off can affect navigation, or the NPCs can't ever get to it. Much better. Now, by selecting an NPC and going to that patrol component we just made, you can drag it around to where you want the NPC to walk to. Now we can save that location and store it to the Blackboard like we did before. Make sure that the key names are all correct. Now, on the patrol to set point task, get those values from the Blackboard for use. I like to save them as a local variable to make it easier to get them later. Tell the NPC to move there and add it to the behavior tree. Oh yeah, they're running again. Copy the walk speed code from the other task and add it in. Allow the task to say if it's finished correctly and test it. As you can see, with how the behavior tree is set, it will run the patrol to set point, then random patrol, then wait. Also, once the NPC is at the patrol point, we want it to go back to the start point. Let's add a key to tell if the NPC should be going back to the start or not. Blackboard Boolean values default to false. We can branch on if we are returning. The false pin is what we have already coded. We just have to change the value when we get there. If you are returning, we move to the start point and change the value of return to false. You can watch the task blueprints to see what code is currently running. What if I don't want them to patrol to a set point? What if I want them to be random again? Plus, I have perfectly good code in my patrol random task that I kind of want to use. Let's add a public variable to our NPC class to decide if we are random or if we walk to a set point. Perfect time to talk about decorators. I find the best use of decorators is to gatekeep the task before it runs and decides if it even should run. Decorators cause the attached task to pass or fail before the task runs. To see if the NPC should patrol to a set or random point, we will perform a condition check AI and just get the patrol random variable from the NPC class and return it. This error is what happens when you add a variable but fail to compile. You can see that the decorator causes the whole sequence to fail. To fix this, we can switch to a selector. Now if the first task fails, because random patrol variable is false, it will try the next one. We still want to run the wait task at the end, so we add a sequence node to run the wait task after one of the patrol tasks succeed. You can invert decorator results as needed. And that's the end of part 1. You should now have an AI-controlled NPC that can either patrol randomly or to a set point and back using behavior trees. A lot of information was packed in here. If it was too fast or unclear, let me know and I'll break down that part better. Hope this helps with whatever problem brought you here or your fresh journey into game development. Thank you for watching.